Here we're going to discuss rolling motion. So here we have a wheel on the ground rolling with an angular velocity of omega and an angular acceleration of alpha. Now this is general plane motion because we have translation and a rotation occurring here. So our rotation is probably the most obvious, but we have translation as well. So if we look at this point C in the center of our object, this point, as this wheel is moving, it's going to be traveling in a straight line. So it's going to be horizontal like so. So our velocity at this point, tangent to the path, horizontal. And we're going to assume here that our wheel is rolling without slipping. And this is our most common case. So rolling without slipping is exactly what you would picture when you look at this graph. You're just picturing a wheel just rolling along a surface. If your wheels were slipping, that would be like if you're in a car and you hit the gas and then your tire starts spinning. So most often we're going to be looking at problems with rolling without slipping. And when you are rolling without slipping, these equations apply. So our velocity at our point C will equal our radius r times omega, and our acceleration of point C will equal our radius r times our angular acceleration alpha. Now, under a no-slip condition, our point A here is going to have a zero velocity. So VA is going to be equal to 0. And that makes this point A our instantaneous center of zero velocity, therefore. So as this wheel is moving, at each instant, whatever is directly on the bottom here in point A's position is going to become our instantaneous center under a no-slip condition only. Now let's look at acceleration. So here we have our same wheel rolling along, rolling without slipping. So at our point C, our acceleration is again going to be only in our horizontal direction. So it will look like so. And we can say because of this, AC will be equal to ACI, and it will have no J component. And at our point A, we're going to have two components of acceleration. So we'll have AY and AX. So our AX, this is going to be equal to 0. Our AAY is going to be equal to R times omega squared. Now, I've written over here in blue on the left some of our derivations, but this is what's going to allow us to say that our y component of our acceleration of point A equals r omega squared, and we can say the magnitude of the acceleration of point C, this is going to be equal to AC equals alpha times R. Thank you for watching. If you like this video, please be sure to give it a thumbs up and subscribe. That really helps support my channel and helps me continue making videos for you guys. I'll see you next time.